Welcome to Akshara IIT classes. This is Srinivas, your maths faculty. Welcome to today's class. Right. So previous class we have started the exercise topics, right? So congruent rule, Fermat's rule, Wilson rule, we have all discussed that. So let us check the problems in exercise. Okay. Yeah, divisibility rules are also completed. Right. So yesterday we discussed this problem, right? If m and n are two co-primes, which of the following is true? If you take any two prime numbers or any two numbers which are having a common factor 1, there is no common factor except 1, such type of numbers are called co-primes or relatively prime numbers, we have discussed, right? No common factor between two numbers are called co-primes or relatively prime numbers. So for them LCM is their product and HCF is 1, highest common factor is 1. So we discussed already. Now let us see the third question. LCM of 3 by 4, 6 by 7 and 9 by 8. These three are fractional numbers. To find the LCM of fractional numbers, what is the formula? Very good. LCM of numerators. Yeah, LCM of numerators by HCF of denominators. So let us see the numerators. What are the numerators here? 3, 6, 9. Okay. Yeah, just look at it. While you are having the numbers like 3, 6, 9, without doing the regular synthetic division, we can identify for some problems like this. For example, what is the highest number among them? 3, 6, 9? 9, right? Now check 3 table, 9 will come. 3 3s are 9. That means simply LCM of 3 and 9 is 9 only. LCM of 3 and 9 is 9 only. Now check 6 table, 9 will come. No, 6 1s are 6, 6 2s 12. 6 table, 9 is not coming. Now I am checking for 9 2s. 9 2s are 18. Now check 6 table. Definitely, yeah, 6 3s are 18. 6 table 18 will come. 3 table also 18 will come. We can say that LCM of these numbers is 18. LCM of numerators is 18. Or else we can check 3, 6, 9 together. Regular division method, synthetic division method. 3 is a prime number. 3 1s are 3. 3 2 6. 3 3s 9. Again, we can use 2 is a prime number. 2 is not coming in 3 table. As it is, we can write now 3 table. All ones. So LCM equals to 3 into 2 into 3. 3 2 6. 6 3 is 18. Same answer. So without doing the regular method, we can identify like that. That means we are just checking in highest number multiples. What is the highest number among them? 9. I am checking for 9 multiples. Because 9 is not coming in these two numbers. Only one number it is coming, second number is not coming. So I am checking the multiple of 9s. 9 1s, 9 2s, 9 3s, like that I have to check. Okay, na? Right. So otherwise we have the regular formula, regular method for finding the LCM of these numbers. Clear? Okay. We found the LCM of numerators is 18. Now let us find the HCF of denominators. HCF of denominators. What are the denominators here? 4, 7 and 8. 4, 7, 8. Let us find the HCF of first two numbers. Always smaller number as divisor, larger number is dividend. 4 1s are 4, 3 remainder. Continue the division. Now the divisor becomes dividend. That 4 become dividend here. 3 1s are 3. Again remainder 1. Again second divisor is 3. 1 table 1 3s are 3. When you get the remainder 0, its divisor become the HCF of two numbers. So HCF of 4 and 7 is 1. HCF means highest common factor. Now while you are observing 4 and 7, both are co-primes. There is no common factor between 4 and 7. That means we can directly write 1 is a HCF. Okay, na? Highest common factor. 1 we got. Now 1 and 8. 1 8s are 8, remainder 0. So HCF of 4, 7 and 8 is 1. Now required answer, LCM of these fractions is, LCM of numerators we got 18 and HCF of denominators is 1. So 18 by 1 is nothing but 8. Our answer is 8. Okay? Yeah, check. Next question. Okay, let us see the next question. The remainder when 28 factorial plus 1, okay, is divided by 29. 28 factorial plus 1 is divided by 29. Okay. What is 28 factorial? Factorial of n, or n factorial is nothing but product of first n natural numbers. So 28 factorial means product of first 28 natural numbers. That means 1 into 2 into 3 into and so on into 28. That means we will get very lengthy answer. For that answer again we need to do 29. Is not possible. That means it will take lot of time. But here while you are observing carefully, we can discuss. We can solve this problem with Wilson theorem. What is the Wilson theorem? What is the Wilson theorem? P minus 1 factorial plus 1 is exactly divided by P, where P is a prime number. Where P is a prime number. Okay, na? So, while you are observing here, 28 is not a prime number, 28 is a composite number, but 29 is a prime number. Now I am writing 28 as 29 minus 1. 28 factorial I am writing as 29 minus 1 factorial by 29. So 29 is a prime number, 28 factorial I have expressed in this way. So simply by Wilson theorem, that entire numerator value is exactly divisible by 29. Exactly divides means there is no remainder. Exactly divides means there is no remainder. So our answer is 0. Because you are asking about only remainder. See, asking about remainder. Okay, na? This is only happens when the number can be expressed as primes. There 28 we can write as 29 minus 1. Then only it is possible. Okay, na? Because 29 is a prime number. Got it? Yeah. Let us go to the next question. Right. So, first congruent rule, A1 is congruent to B1 modulus of n, or A1 is congruent to B1 mod n, A2 is congruent to B2 mod n, then the correct one is, I told you already, A congruent to B modulo n or C congruent to D modulo n, then A plus C is congruent to B plus D. That means while you are doing addition, A plus C, B plus D, or multiply A into C, B into D, or subtract A minus C, B minus D is modulo n. Am I right? So same, let us apply for this addition, subtraction, multiplication we need to apply. We'll check. A1 plus A2 is correct. but A1 plus B2 is given. So first option is not considered. Right. Second option, A1 here, minus symbol with subtraction. A1 minus A2, LHS part correct. But RHS part is B1, it should be minus, but here B1 plus B2, so second option also wrong. Next, coming to the third, A1 into A2 equals to, A1 into B2. But what should be actually? A1, A2 is congruent to B1, B2 modulo n. So this is also wrong. Last option, A1 plus A2 addition is congruent to B1 plus B2 modulo n. Yes, only the option 4 is true. Our required answer is 4. Okay, na? This we can discuss by the properties of congruence, congruent rule. Okay, na? That means if A, B and n are 3 integers or 3 positive numbers, we can express them A congruent to B modulo n, where n divides A minus B or A minus B is divided by n. Then only we can express in the form of congruence. Okay, na? Right. Let us go to the next problem. Right. 17 minus 1 factorial plus 1 is divided by. Now tell me that answer by using the Wilson theorem. What we have discussed previously. P minus 1 factorial plus 1 is divided by P, where P is a prime number. Here 17 minus 1. 17 is a prime number or not? Yes, 17 is a prime number. So we can say our answer is 17 by Wilson theorem. Okay, na? Next. Yeah, 4 cube is congruent to x modulo 3, then x equal to. So do you remember the Fermat's theorem? What is Fermat's theorem? A power p minus 1 is congruent to 1 mod p, where p is a prime number. Here, where p is a prime number. That means p is a number from the set of prime numbers. Okay, na? Here, this Fermat's theorem we can express in another way also. That is, a power p is congruent to a mod p. Just compare this one. 4 cube is congruent to x mod 3. 3 is a prime number. 3 is a prime number. So a equals to 4. What is here? A. In the place of x, what should be? Very good. It is 4. Therefore, x value is 4. Fourth option. So Wilson theorem and Fermat's theorem, some congruence rule, you should remember this. Okay, children? Shall we go to the next? Excuse me. Yeah, next problem. Right. Eighth one. First one same like sixth question. A1 is congruent to B1 mod n and A2 is congruent to B2 mod n. Then among the following incorrect statement. So when you have two congruent rules, we can add both of them, LHS and RHS separately, and we can subtract them, we can multiply them. Let us check 3 of them are there in the note. The first one, A1 plus A2 equals to is congruent to B1 plus B2 mod n. B1 plus B2 mod n. Yes, this one is true. This one is true. Now second one, A1, A2 is congruent to B1, B2. That means multiplication. First congruent rule and second congruent rule, we are multiplying. So A1, A2 is congruent to B1 modulo 2. It is also true. Coming to third, A1 plus B2. A1 plus B2. But actually it is in the place of A1 plus A2 is congruent to B1 plus B2. But LHS and RHS we cannot mix like this. So this is the false statement. And last one, A1 minus A2 equal to B1 minus B2. Subtraction. This is also true. So what is our required answer? Third one. Because they are asking about the incorrect statement. Okay, na? Next. Let us see the next problem. Okay. The units digit in 3 power 4n plus 3. 3 power 4n plus 3. We know already 3 power 1 is end with 3. 3 square end with 9. 3 cube end with 27. That means 3 cube means 27. Nothing but end with 7. 3 power 4 end with 1. Again the cycle is repeated. Sorry. Again the cycle will be repeating. That means 4n plus 3. First one 4n plus 1, 4n plus 2, 4n plus 3. So it is end with the digit 7. Okay, na? Clear? Yeah, very easy problems. Okay, let us see the next question. Right, multiple choice questions are there. LCM of 1 by 100, 1 by 200, 1 by 300, 1 by 1000. Now LCM of fractions. Check. How to do the LCM of fractions? Very good. What is that formula? LCM of numerators by LCM of denominators. So LCM of numerators by HCF of denominators. Okay, na? Now while you are observing the LCM, that means numerators, from the all fractions we have only the numerator 1. Among them LCM is 1 only. LCM of numerators is 1. Because all are same numbers, its LCM will give the same number. Obviously. Next, HCF of denominators. HCF of denominators. What are the denominators here? 100, 200, 500 and 1000. Yeah, HCF of first two numbers 100. Otherwise, check once. 100 table is the smallest one. 100 is the smallest among them. This 100, in 100 table all the numbers are coming or not? Yeah, here 2 times, here 5 times, here 10 times. So we can consider the smallest among them as HCF, or we do like this. First 200, 200. 100 table how many times? Yeah, HCF is 100. Again 100 and 500. Because from these two HCF 100, with that HCF and second one, 100 table 5 times. Yes, again 100 will be the HCF. Again with 1000, 100 will be the HCF. Therefore, required answer is LCM of numerators 1 by HCF of denominators is 100. So our answer is 1 by 100. Our answer is 1 by 100. Excuse me. Okay, children, let us see the next problem. Okay, it is also based on the congruent rule. What is the first congruent one here? 17 is congruent to 3 modulo 7. 17 is congruent to 3 modulo 7. Right. Second one, 9 is congruent to 2 modulo 7. 9 is congruent to 2 modulo 7. Then which of the following are true? So first LHS addition. 17 plus 9. Yes. First option. 17 plus 1 plus 9 is congruent to RHS parts. 3 plus 2 is modulo 7. If here first one is modulo 7 and second one is modulo with some other number, we cannot apply any properties between them. Okay, na? They must be same. Yeah. According to the first option is true. Let us go to the second option. 17 plus 7, 9 plus 7. That means one constant you are adding both sides. Okay. Let us see the third one. We'll discuss this one later. Let us see the third one. 17 into 9, 3 into 9. That means while you are applying multiply with an integer, you have to multiply with the same number. Left side is multiply with 9, but right side is multiply with 2. Third one is not our answer. Let us see the fourth one. Fourth one is 17 minus 9 is congruent to 3 minus 2 modulo n. Okay. So before that, we can find this one by solving the answer also. That means by using the congruence condition. So first one is true, no? Sorry, here also changes. Yeah, 17, 9, 3, 2. Yeah. Both sides are same. Both are multiplies. Here both are subtracted. Right. So here 17 minus 9 is congruent to 3 minus 2. Yes. First one and second one we are subtracting. So third one is correct. Third one is correct. Fourth one is also correct. And let us see the second one. 17 plus 7. One constant we are adding. That is equals to 9 plus 7. But check here. For this one you are adding 17 plus 7. 17 plus 7 how much? 24. 24. Yeah, 24. This one 9 plus 7. 16. 24 minus 16 is not possible. Actually, from the both congruent rules we cannot apply like that. You can add both of them to any one of them. That means 17 plus is congruent to 3 plus 7 modulo n. But here 17 plus 7 is congruent to 9 plus 7. 9 is in the second congruent. Here 3 is in the first congruent. If you apply it is applied in the place of 9. If it is 3, yes, the rule can be correct. But it is not given like this. So only 1, 3, 4 is our answer. Okay, na? Next question. Let us go to the next question. Yeah, units digit. 7 power 2012. Now what is 7 rule? 7 power 1 means 1. 2, 3, 7, 8. We have discussed it. 2 power, 3 power, 7 power, 8 powers. These are all having repeating the sequence after 4 terms. It means all should be right in the form of 4 terms. That means 7 square value 49, 7 cube ends with 3 and 7 power 4 end with 1. Sorry, 7 this one. 1. Okay, na? So while you are checking here, last 2 digits is 12. That means 2012 you can directly divisible by 4. We discussed already 4 rule, right? last two digits are multiples of 4 or zeros, then the entire number is divisible by 4. That means it is not leaving any remainder. That means 4n plus 0. 4n plus 0 is nothing but 4n plus 4. 4n plus 4. That means it is ending with the digit 1. Unit digit of this number is 1. Okay, na? Let us go to the next problem. Okay. Question number 5. See here, there are two ropes, each measures 496 meters and 624 meters. This is meters. Measurement is given. Okay, two ropes, each measures 496. That means first one length is 496 meters, so second one is 624 meters. The largest scale that would be used to measure both of the ropes exactly. Okay. Like we have discussed previously, like one of the example, like if there are three schools A, B, C, they are ringing the bell for 30 minutes, 45 minutes and 60 minutes. If they start ringing together, when they start again. That means when they ring together. Am I right? For that we are using least common multiples. But here asking clearly largest scale to measure these two. That means if you take 624 meters length of square, you cannot measure 496 because 496 is less than that scale. Okay, na? That means where you are counting like how many times you can measure with the scale. Let me tell you one real life example. Like if you have the milk in a can, to measure that milk we are using 1 liter jug or 1 liter jar or 2 liters jar or 5 liters jars, like that. Like 3 jars, one is containing 2 liters, one is containing 3 liters or one is containing 5 liters. So what is the largest mug or largest jar to measure these three quantities? Okay, for example, if you take 2 liter jar, you cannot measure 3 because in 2 table 3 is not coming, in 2 table 5 is also not coming. If you use that 3 liter jar, you cannot measure 2 liters exactly. Okay, na? Without, that means it is not giving any marking on the jars. Because 3 table 2 won't come, 3 table 5 won't come. Same way 5 also not usable. But here we need to measure them all the 3 jars by using 1 liter jug, 1 liter jar, because HCF of these 3 is 1. 2, 3, 5, 3 are prime number, there is no common factor except 1. So HCF will be 1. So we can use 1 liter jar to measure these 3 quantities. Okay, na? In same way, to measure these two quantities, 496 and 424, we need a common factor to measure both of them. That means we have to identify the common factor between them. That is the largest scale to measure both of them. That means 10 times or 20 times, like that. Not 1.2 times, 3.5 times, not like that. We should not take as decimals. We have to take only whole numbers. 1 time, 2 times, 3 times, like that. So for identifying this, we need to find HCF of both of the numbers. So smaller one 496 and larger one 624. Find the HCF. Ones are 496. Yeah, here 8, one remainder means 11 to 128. Again 496. I think 4 times will come. 4 twos, yeah, not coming. 3 times we check. 3 times 3 8s 24, 3 2 6 plus 2 8, 3 ones are 3. 112. Again, 1 time 112, will give 16. 16 table here, nearly 5 times 6. Let us see, 7 times. Yeah, it is coming exactly 7 times. So when you get the remainder 0, its divisor is our answer, 16 meters. So if you have the 16 meter scale, you can measure exactly 496 and 624 as whole number of times. Okay? Let us see the next problem. Right. A value is 17, B value 8, C value 3. Then once check the 4 options, the modulo of C, all are given in the terms of C. When it is possible, if A, B, C can be written in the form of congruence, A is congruent to B modulo C, that means A minus B value should be divided by C, then only it will be worked out. Let us apply this. 17 minus 8 by 3. 17 minus 8 how much? 9. 9 by 3, yes, it is exactly divides. So 17 minus 8 divided by 3. So we can write A minus B is, third one. A minus B is congruent to 0 modulo C. Okay, no? That means while you are bringing this side here minus, it will be 0 only. So option C are required answer. Next, 7th question. So this is nothing but A square, here B power 4, that equal to 16. C value is 5, then we have to identify the required. So actually I can make it into A square value is 16 and B power 4 value is also 16. Let us find out the A value and B value first. See, 16 is a square number. I can write 16 as 4 square. 4 4s are 16. Both sides square cancel, then A value is 4. That means we are applying the square root both sides. Now here, B power 4, that means 16 you find prime factors. 2 8s, 2 4s are 2 2s, 2 1s. 2 into 2 into 2 into 2, 4 times. So 2 power 4, so B value is 2. What is C? C is 5. So 4 minus 2 is divided by 5? No chance. A plus B, 4 plus 2, 6. Let us go through the options. 4 plus 2, 6. 6 minus 3, 3. 3 is not divided by 5. So option 1 is wrong. A value is 4, B value is 2, 4 plus 2, 6. 6 minus 1, 5. 5 is divided by 5 because modulo 5. Option 2 is right. Let us check for remaining also. Here 4 plus 2, 6. 6 minus 2, 4. 4 is not divided by 5. Here also 6 minus 6 is not divided by 5. So only the option is 2. Okay, na? So first of all you need to identify the values of A and B. Then check through the options. Okay? Right. Yeah, that's it for today, children. Thank you, one and all. Have a nice day.